Hello everyone, welcome to today's session, Enable Interactive Data Analytics at Petabyte Scale with Amazon EMR Studio. Myself Kalyan Janaki, I'm a Senior Big Data Analytics Consultant at Amazon Web Services. Looking into agenda, we'll start our session with a brief overview about Amazon EMR. Then we'll see what is the typical data science and data engineering flow and what our customers have asked us. Then we'll discuss what's an Amazon EMR Studio and what are a few features that Amazon EMR Studio makes it easy for data scientists and data engineers in organization. And finally, we'll see a demo on about how to create an EMR Studio and how to log in into EMR Studio and perform interactive analytics on large data set using notebook interface. Without further ado, let's start our first introduction to Amazon EMR Studio. Amazon EMR is a way to run big data frameworks inside AWS. Whether it's Spark, Hive, Presto, Flink, essentially with a single click of button, you can spin up a cluster and run it in AWS with these different frameworks installed on it. This cluster can be 1 node, 10 nodes, thousands of nodes, and it can scale up and scale down dynamically in response to your workloads. One big thing about EMR is we keep up to date with the latest open source frameworks, generally within 30 to 60 days. So with EMR runtime of Apache Spark or EMR runtime of Presto, you get performance benefits that helps your workload sometimes to run 2.5 times faster as compared to the open source versions. You can also get reduction in the cost by using EC2 spot instances. And of course, there is per second billing, so you can spin up the cluster and perform your workloads and spin down the cluster so you get charged for the amount of resource used. Being able to spin up the cluster and read the data from S3, perform your data processing, and then write back the output to S3 and shut down the cluster is really beneficial. EMR provides a fully managed scaling, and without any configurations from the administrators, the cluster can scale up and scale down based upon your Spark and other Apache workloads. EMR allows you to choose different types of EC2 instances. You can choose compute optimized instances for your compute intensive jobs, and then you can choose memory optimized instances for Spark jobs. And also you have an option to choose GPU instances for your ML workloads. Let's go ahead and discuss the different EMR deployment options. In the past, you might be used to EMR on EC2. So basically you go in there, spin up your EC2 instances, and the cluster is provisioned with you with the framework installed on top of it, right? A couple of years back, we also announced EMR on EKS. So if you are running Kubernetes on AWS, now you can run Spark jobs using EMR runtime directly on top of EKS. Last year, in reInvent, we announced EMR serverless, where you can run Spark and Hive jobs on a completely serverless EMR cluster, where you don't have to manage any hardware provisioning and EMR takes care of that. So if your organization needs ability to allocate the cost per cluster, then EMR and EC2 would be the best option. But if you are looking into an with cost per application, then EMR and EKS, and if you are looking into cost per job, then EMR serverless might be a suitable option. All the deployment options get the same data plane bits. That means they all get the same distribution and they all get same benefits of EMR optimized runtimes. Let's go ahead and see what exactly Amazon EMR customers told us. Here is what our customers told us. Firstly, they want to use corporate identity to directly log in into the notebooks instead of using AWS console. Secondly, they want to be able to access fully managed notebooks instead of self-managed Jupyter hubs. They are also looking for a simple way to connect to the code repositories and collaborate their development on top of these notebooks. They're also looking for a simple way to run these notebooks as a pipelines or jobs using standard orchestration tools like Apache Airflow or Amazon Step Functions. And then they want to submit these notebooks onto the clusters that have already been created or they want to use templates to create the clusters so that they don't have to worry about all the complex EMR configurations and their data platform administrators can take care of it. They want to use multiple notebooks on a same cluster so that they can take advantages of multi-tenancy and save costs. Finally, they are also looking to simple way to debug their jobs so that they can directly debug the jobs using the application user interfaces from the notebook interface instead of having to log into the EMR cluster. With looking into all these requirements, we have introduced Amazon EMR Studio to address all these customer requests. Amazon EMR Studio is a notebook-first IDE experience for data scientists and data engineers to automatically provision the infrastructure and perform job diagnosis from an integrated development environment. Let's go ahead and take a look at some of the features of EMR Studio. EMR Studio makes it simple for you to run applications on EMR clusters. You can access EMR Studio using your corporate credentials or AWS single sign-on without having to log in into an AWS console or EMR cluster. You can interactively explore, process and visualize data using notebooks, build and schedule pipelines, and also debug the applications without having to log into the cluster. You can start developing analytics and data science applications written in R or Python or Scala or PySpark within seconds. When you run EMR Notebook, Jupyter kernels and applications run on your EMR clusters. As a result, you get the benefit of distributed data processing with performance optimized runtime for Amazon EMR for Apache Spark. You can attach your notebook to an existing EMR clusters, or you can provision the new clusters with the pre-configured templates. You can collaborate with your peers by sharing notebooks via core repositories, and you can also load custom kernels directly from notebooks. You can simply run notebooks as a pipelines using orchestration services such as Apache Airflow, Amazon Managed Airflow, or step functions. You can access native application UIs like Spark UI, Yarn Timeline Server directly from EMR Studio without having to open connections to your EMR cluster or without having to log into an EMR cluster. With all these features, now it's time for a demo. This is the interface of EMR console, and if you have already used EMR, this should be a pretty familiar interface for you. We have a list of clusters, and you can see I have two clusters here. One is in starting state, other is already started and waiting for the jobs to be submitted. To create a cluster, you can click on the create cluster button and just provide the name of the cluster, and this is pretty simple interface. You'll go select the version you are interested, provide number of instances, and click on the create cluster button. We also have an advanced option. When you choose an advanced option, you would choose a release version, pick the list of softwares that you want to be installed on your cluster, provide the list of steps, and then you have an option to choose either uniform instances or an instance fleets. You can provide more advanced details like networking, different combinations of instance type. As you can see, in the advanced cluster create configuration, it gets a little complex, and a typical data engineer or data scientist would have to spend a few iterations before they get perfect about this cluster creation process, right? On the other side, organizations want data engineers and data scientists to spend more time on analytics and machine learning instead of trying to learn these complex EMR configurations, and they would want their data platform administrators to take care of this cluster configuration and create templates for data engineer and data scientist. So that the data scientists and data engineers can directly log in and use the templates to create the cluster and start working and processing the data. So now that we looked into EMR console, let's go ahead and see how an EMR Studio looks like and how to create an EMR Studio. So to create an EMR Studio, you'll have to click on the EMR Studio link on the left side menu and then click on the Get Started button. This would take you to an EMR Studio console. So you have two options. One is AWS Service Catalog and Create Studio. We'll discuss more about Service Catalog later. As a first step, the data platform administrator needs to create a studio so that users can log in into Studio and start working. So click on the Create Studio. So users can provide their studio name and the studio description. After providing the name and description, the next step would be choose the networking configuration. You'll have to select the VPC and subnet details. It is suggested to choose the same VPC and subnet where your EMR clusters would run so that they can directly access the EMR cluster. After providing networking configuration, you are expected to provide two security groups, one for cluster endpoint security group and other for a workspace security group. The cluster endpoint security group is for a Studio engine to access an EMR cluster, and the workspace security group is for the workspace that are created by users to access the Studio engine. After providing security groups, then about the user management, EMR Studio support two options. Either you can use IAM Federation using your corporate credentials, or also you can use AWS Single Sign-On, which was very recently rebranded as IAM Identity Center. In this example, I'll be using AWS Single Sign-On, and we'll have to provide two IAM roles, the Studio service role and the user role for the user who logs in. And then the last configuration item is you'll have to provide an S3 location so that all the information like the workspace information, the notebooks that are created by data engineers and data scientists would be saved in this location. So we'll go ahead and click on the Create Studio button that would create a studio. Now that Studio is created, the next step would be is to go ahead and add the users so that they can access the Studio. So click on the Studio, go to the Users section and click on Add Users, which would show you a list of all the users that are available in AWS SSO. I have created a couple of users in SSO, so we would go ahead, select a user and add them so that they can access EMR Studio. By default, when a user is added, they get an administrative access. So we'll have to go ahead and change the IAM role so that the data platform administrator can give the user only permission to create an EMR cluster through the templates and submit the Spark jobs or other big data jobs. Once you update the policy, the user would have access to EMR Studio. So if you go back to the Studio homepage, so next time for users to log into the Studio, they would never need to log into AWS console, and Studio provides its own URL. So users can bookmark this URL and directly use this URL to log into the EMR Studio and start creating notebooks and submit it. Okay, now that we have access to Studio URL, let's go ahead and log in as a standard data engineer and data scientist. So we'd go ahead, select the URL which takes you to the credentials page. So I will go ahead and provide my AWS SSO credentials. So I'll put my username and password here, which takes me to the EMR Studio homepage. So this is the Studio homepage for the user logging in through SSO. And you can see we have different options to launch serverless applications and manage notebooks. So we have sections for Workspace and EMR clusters. On the cluster, we select an EMR and EC2. You can see there are 3 clusters. A couple of them are active and one of them is in terminated state. So as a first step is to go ahead and create a workspace so that you can user can work in his own workspace, right? So go to the workspace section and click on the create workspace to start creating the workspace. So all you have to provide is the name of your workspace and description. The S3 location for workspace is automatically picked from your EMR Studio configuration. And there are a couple of advanced configurations that you can use. So open on the advanced configuration where it provides you 4 different options for the cluster, right? Either you can create a cluster or attach an existing cluster or use a template provided by your data administrator, and you can use EMR and EKS, but we'll use it later. So let's go ahead and create a workspace. So creation of workspace definitely takes a few minutes. Let's go ahead and see how the workspace looks like. Okay, now that our workspace is ready, we can click on the workspace link, which takes us to the workspace homepage. This is the homepage for EMR Studio Workspace, and which is similar to the Jupyter Hub. As you can see, there are different notebook kernel types available like Python 3, PySpark, Spark, and SparkR. We also have a terminal and notebook example section. On the left side, you can navigate to File Browser, which can access all the notebook files that have been that you are working in your workspace. And then there is a section for clusters, where you have option for different types of clusters. So you have option for EMR on EC2 clusters or EMR on EKS clusters. So you have a drop down where you can select the list of already running clusters. So here we have one cluster that's already running. In advanced configuration, you have options to create cluster or use a template that have been enabled by Data Platform Administrator. So let's go ahead. In our example, I would love to use cluster template. So let's go ahead and click on the cluster template. How are these templates created? So we'll have to navigate to Service Catalog to see how these templates are created. AWS Service Catalog is a service where the administrator can create products and bunch of portfolio products under them. Here in our example, we have a portfolio with couple of products with product name as EMR 6.2.0 and EMR 5.3.0. And within the products, you have product versions, and then each of this version is a separate template. So Data Platform Administrator can create templates of EMR clusters so that they can abstract the complex configurations away from data engineers and allow them only to use the standard configurations like number of instances and type of instance. So here I would use 6.2.0, select 5 instances, and go ahead and create a cluster which starts spinning up the cluster in the background. Well, this cluster is being created. Let's go ahead and look into other section for Git Repository. You can see I've already cloned the demo repository here, but any point in time, if you want to work on new repository, you can click on the Git Repository, add new Git Repository button, which would provide you options to name the repository directly that you want in your notebook, and you'll have to provide your repository URL, the branch, and then the credentials. So I've, as an example, I have already cloned the demo repository. So whatever the repository that you connected here would be available in your file browser as a directory. You can see I have a demo repository directory with a sample notebook inside it. So you doesn't have to be expert to start using EMR Studio and Jupyter Notebook. When you just created the EMR Studio, and if you are not aware where to start from, you have a section for notebook examples where we have made bunch of different types of notebooks that you can start with. So all you have to do is create an EMR Studio, add an user, log in into it, and exploring with different sample notebooks that are made available. Okay. Now let's dig into the demo. Before we start doing the interactive data analytics sample demo, I would like to talk about data sets that we're going to use in demo. If you're not aware of Registry for Open Data AWS, I would highly recommend to go ahead and take a look. It's a location with lot of open source data sets that are available on AWS for users to try it out for their data analytics and data science practice. I'll be using a couple of data sets in our upcoming example. The first data set is open air quality. The open air quality is a global aggregated physical air quality data from public data sources across the world in different cities with the sensors sitting in different locations in a particular city. The second data set I would be using from the same registry for open data is a NOAA Global Surface Summary data, which is nothing but a weather data across different cities which contain the average like temperature, dew point, and sea level and different weather parameters. So basically the example is I would be, as a data scientist working in, I would go ahead and see how you can perform data analytics and machine learning to look into the relationship between air quality and this weather data. So we are on the home page of Jupyter Hub, and then I'll go ahead and first I will attach my workspace to an cluster. So I'd go ahead and choose the EMR on EC2 cluster option. I will go to the drop down and select one of the cluster and click on the attach cluster button, which would go ahead and attach my workspace to the EMR cluster. So the workspace is successfully attached. So I'll go ahead and open the notebook air quality predictions. So the first shell in the notebook is trying to install FoodPathon libraries. I've already installed it previously, so I will be skipping this cell and directly going to the data preparation step. The first step is to read the air quality data and pull out the sample schema. So I would be reading a sample file from the S3 location and trying to print the schema. As this is the first cell that we're executing, we'll be starting a Spark application. So as you can see, we are spinning up the backend yarn application with an application ending 004, and we'll be start using that application in rest of our data processing steps below. So the job has kickstarted and it's progressing. It's trying to read the file and get us the JSON schema. Okay, you can see a sample JSON schema of a row is available on the screen here. We can see the standard schema value here is an average value, city, coordinates, location, country location, date time, and then the Invo2 parameter. And the next step would be we will be reading all the data sets for past history and trying to filter it to the Seattle location and only for the parameter NO2, because NO2 is the parameter that represents the air quality. I'll go ahead and execute this. So this is actually reading the whole data for history and trying to filter the data, apply two filters. First is on the city to filter for Seattle location, and then apply filter on NO2. So we got a sample rows output. You can see here the city location is always Seattle, and then we have a Seattle coordinates, and then we have the different timestamps, and then the NO2 parameter over there. The next step is we have this air quality collected in a different locations or different timestamps in a day, but we want to aggregate this data set to calculate the average air quality across the city by grouping up and aggregating these values for each single day. So we'll be go ahead and submitting an aggregate operation here. So as you can see, we are grouping over the day and aggregating the value to calculate the average. As this is a huge aggregation across the historical data set, this job is going to take a couple of minutes. So while this job is progressing, we'll go back to the workspace and click on the clusters and try to look into debug URLs. So to enable debug URL, you can click on the cluster here, and you can see on the top right there's launch application UIs. I'll click on the Spark history server. While the Spark history server is being launched, I'll go ahead and see the progression of our job. Okay, that looks cool. Our job has successfully progressing here. Well, this job gets progresses. Let's go back and see if our application UI is launched. I'm going back to the EMR Studio other tab. Okay, let me open my pop-up blocking. I'm opening the Spark UI here. Okay, which takes us to Spark history server. As you can see, we have historical applications with ID ending 2 and 3, but we are interested in our current applications. To click on the incomplete application, which would show us an application 004. Let's confirm if it was the same application. We can go back, scroll to the top, and it's the same application that our current notebook is working on. So let's go back and click on the application, which takes us to the Spark UI for this application, Yarn application. So this is the Spark UI, which you can debug. So as you can see, it's so easy. So without having to log in into an EMR cluster, you are able to debug the live job that you submitted in Notebook here. So I'll go to the next stages tab. As you can see, there are like 412 tasks running, and you can click on the executors tab to take a list of all executors. So this displays different executors. We can go ahead and sort on the status to see the active executors. So I'll click on the sort, which will show you all the active executors, with each executor running 4 tasks with 4 vCores allocated to them. We can go back to our notebook and see the progress of our job. Okay, the job is successfully completed, and we have an output, a sample output here. As you can see, the average value of NO2 calculated across each single day. Now that we have processed the huge historical data and got an aggregated value, we want this smaller aggregated data set to the local workspace so that we can do Python. You can do data analysis using standard Python libraries. So for this, I would be using a Spark magic command, spark-vo, which would pull out the data from Spark distributed environment back to the workspace local. So that's successfully executed. So I have this data frame into the local. I can use the Python libraries like matplotlib and seaborn and plot the values. So I'll go ahead and plot the NO2 average over the years. So which will display the as you can see from the plot, we have the NO2 average distributed from year 2016 to 2022, but on the end of year 2018 we have some spikes that shows that the data is missing. So let's go ahead and see what exactly happening in the data set to try to print out the data set over the between October and November of 2018. Okay, and then okay, as you can see from starting 14th of October and for multiple days we have the average value missing here. So we would go ahead and do some data science operation to interpolate the missing values of NO2 average for all those days. I would go ahead and execute this block of code which would go ahead and interpolate the values. Okay, now that we have fixed the missing data, I would want to go ahead and pull out the year minimum and year maximum because I would want to use the same years to process my other data set. So now that we have this variables year minimum, year maximum in local, I would want to send this variable to the distributed Spark environment in the EMR cluster. So I would be using another Spark magic command called send to Spark, which would take the variable from local workspace and send it over to the EMR cluster or else the Spark distributed environment. Let's go ahead and execute these couple of blocks so that we can send both the year minimum and year maximum variables. Okay, now that we send successfully these variables, we'll have to go ahead and pull out the weather data set for exact range of the years that we have just passed on. So I'll be executing the next piece of code. I know there's a lot of code. Let me first execute this block and then explain you what exactly is happening here. So basically what I'm doing is I'm going ahead and reading this NOAA global temperature data set and trying to apply filter across the Seattle coordinates. So basically I'm only reading the data set for a particular year, whatever the years, and applying filter on Seattle location using latitude and longitude values, and then modifying the header and pulling out a few columns that are of our interest, and also trying to see and fill up few missing values. Now that the job is successful, the next step is I wanted to pull out these data frame, whatever the temperature variables called Seattle features to the local. And now that we have two data frames, we have air quality data and also Seattle temperature data. So let's go ahead and do some analysis on the Seattle weather data. So I will be first plotting the temperature minimum and temperature maximum. As you can see, as the temperature is perfectly plotted with the temperature rising in summers and temperature falling down in winters here. And next thing is we'll go ahead and see wind average. So the wind average is spread across the different values over the years. And then the next thing is we'll be looking into visibility. Seattle being a very cloudy city, you can clearly observe sometimes visibility clearly drops. Okay, it drops so much down as if it looks like it's going to zero. Okay. So next step is, as we'll have to compare the air quality to the weather data, we'll have to go ahead and marry these two data sets. So I'll be go ahead and doing the merge operation. So let's go ahead and run this code here, which would be merging both of our data frames across the different individual days. So the merge has been successful. We'll have to go ahead and see a correlation between the air quality with the weather data set. As a first step, we'll see if there is any relationship between the air quality to the wind average. As you can see, there seems to be some inverse relationship between air quality to the wind average. Next, we'll take a look if there is any relationship between air quality and visibility. So the next block we'll be executing, which shows us the air quality to visibility. You can see it's just almost a straight line, and we really don't see much relationship between air quality and visibility. Next, we'll go ahead and see if there is any relationship between air quality of current day to the previous day's air quality. So we'll go ahead and plot this variable. Wow. There's definitely seems to be a strong correlation of current day's air quality to the previous days of air quality. So if there is some issue in the air quality, it seems to be in a consecutive days here. That's definitely a good observation here. Then we'll go ahead and run some correlation matrix for a different variables for thin air quality like temperature minimum and maximum. As you can see, this is what I wanted to show as an interactive data analytics. What exactly did we do? Okay, as a data scientist coming in, without logging into an EMR console, I've logged in into an EMR Studio. I've just created my workspace, I just created my cluster, attached my workspace to a cluster, and immediately started using a Jupyter notebook to perform a interactive analytics and my machine learning or data visualization on large data sets. So in a single notebook, I'm able to use Spark and then get the data from Spark and apply the Python libraries and perform my analytics. This ends our demo of how to use EMR Studio for interactive data analytics by data engineers and data scientists. And then I would go ahead and look at other features of EMR Studio. Even though many data engineers and data scientists are comfortable using notebooks and using PySpark and Python code, we often have an organizations that are interested to use an SQL. So we have data analysts in organization who are always interested to use an SQL. So we have introduced recently an SQL browser. So once you click on the SQL browser, so you can choose which would be connected to your EMR cluster. You can choose the schema and which would automatically show you list of tables. So this connects to the Glue catalog. I've already made few data sets available. So you can click on the open editor and you can start writing SQL queries, which would automatically take you show you the results. So backend, what is happening is, so when you submit the job here, the job is submitted to the Presto cluster or Trino cluster running on the EMR. As you can see, we have around bunch of reviews in the Amazon reviews Parquet table. You can run other different types of queries. So I would go ahead and see different product codes in our Amazon reviews dataset here. So every time you want to open a new tab, you can click on the open editor so that you can parallelly submit multiple queries and to the cluster and work concurrently. And as we previously discussed in initial slides, EMR Studio provides multi-tenancy so that different users can log in into different workspaces and use SQL browsers and multiple notebooks and submit multiple jobs to EMR clusters. This ends our session today. Thanks for attending the session, and it was great delivering this session to you all.